We just finished the biggest map ever made of the universe. 47 million galaxies, 11 billion years deep. A single picture that holds a meaningful fraction of everything that exists. And it shows two things at once. The first is the most beautiful structure in nature, the way every galaxy is strung together across the dark. The second is a problem, because buried in that map is a measurement that quietly broke the one rule we were using to predict how the universe ends. For 100 years we thought we knew the ending. This map just took that away, and what's left in its place is, honestly, more unsettling. This is First Signal. Today, let's go through the largest map of the cosmos ever built, what it took to make, what it reveals about where we sit inside it, and the single number hiding in the data that has cosmologists quietly rewriting the future of everything. Start with the machine, because what it does is almost absurd. It's called DESI, the Dark Energy Spectroscopic Instrument, sitting on a telescope in Arizona. At its heart are about 5,000 tiny robotic fibers, each one able to swivel and lock onto a single galaxy at a time. Every 20 minutes, it repositions all 5,000 and grabs 5,000 more. For each galaxy, it doesn't just record a dot of light. It splits that light into a spectrum and measures how far it's been stretched by the expansion of the universe, which tells you how far away the galaxy is and how far back in time you're looking. Do that tens of millions of times and you stop having a flat photo of the sky, you start having a map with depth, a real three-dimensional model of the cosmos. And in 2026, they finished it. 47 million galaxies and quasars, reaching back about 11 billion years. The largest, most detailed map of the universe humanity has ever made. So what does the universe actually look like when you finally pull back far enough to see it whole? It looks alive. Not random, not evenly scattered, but threaded. The galaxies aren't sprinkled like sand, they're strung into glowing filaments, thread upon thread of them, joining into walls and knots where thousands of galaxies pile together. Cosmologists call it the cosmic web, and the name is exact. It looks like a web, or the inside of a brain, or roots through soil, the same branching pattern scaled up to the size of creation. And between those threads is the part that quietly resets your sense of scale: emptiness. Vast, dark voids, hundreds of millions of light years across, with almost nothing in them at all. Most of the universe, by volume, is not galaxies, it's the gaps between them. Find our galaxy in that map, and it isn't at the centre of anything. It's one bead on one strand of one filament on the edge of one of those voids. The whole of human history happens on a single dot, in a single thread, in a structure so large the map had to span 11 billion years just to hold it. That alone would be a humbling video, but it's not why this map matters. The reason it matters isn't in the picture, it's in the math underneath it. Because DESI wasn't really built to make a pretty map, it was built to weigh a ghost. About 68% of the universe is made of something we cannot see, cannot touch, and barely understand. We call it dark energy, and all we really know is what it does. It pushes. It's the reason the universe isn't just expanding, but expanding faster and faster every year, galaxies racing apart at an accelerating pace. For decades, we made one core assumption about it, that dark energy is constant, a fixed property of empty space itself, the same strength yesterday, today, and a billion years from now. That assumption has a name, the cosmological constant, and almost everything we say about the future of the universe is built on top of it. DESI's map was precise enough to finally test it, to trace across 11 billion years whether the push has held steady or changed. It looks like it changed. The data hints that dark energy was stronger in the past and has been weakening over time. As the team behind it put it, the acceleration we measure can no longer be explained by a constant. One of them called it a major paradigm shift. The fixed, unchanging force we built our cosmology on may not be fixed at all. Now, I have to slow down hard here because this is exactly where headlines lie to you. This is not a confirmed discovery. In physics, the gold standard for real is 5 sigma, a 1 in 3.5 million chance of being a fluke. DESI's hint is sitting around 4. Strong enough that the whole field is paying attention, not strong enough to bet the universe on. It could still soften back into nothing as more data comes in. So the honest sentence is this: Dark energy appears to be weakening. The evidence is serious but not yet decisive, and DESI keeps observing through 2028, with other observatories lining up to check it. We are not at we know. We are at we might have been wrong about the biggest thing there is. And that's the quiet thing I promised you at the start, the reason this map took away the ending. Every prediction we have for how the universe dies hangs on this one property. If dark energy is constant, the future is settled and bleak. The universe expands forever, faster and faster, galaxies blinking out of reach one by one until the sky goes dark and everything cools toward a frozen, silent heat death. Cold, but at least it's an answer. Take away constant and you take away the answer. If dark energy can weaken, then it can keep weakening. And a universe where the push is fading is a universe whose ending is suddenly back up for grabs. Maybe expansion slows. Maybe it eventually stops. Maybe, in the most extreme version, it reverses, and everything that has been flying apart since the Big Bang begins, over unimaginable spans of time, to fall back together toward a collapse. I want to be clear that the collapse scenario is the far edge of speculation, not a prediction. But that's the point. We don't get to pick the ending anymore. For a century we had one. This map replaced it with a question mark. There's something almost funny about how this went, in the way the universe is sometimes funny. We built the most ambitious map in the history of our species. We aimed 5,000 robotic eyes at the sky, captured 47 million galaxies, reached back 11 billion years, an achievement that should have made us feel like we'd finally gotten our arms around the cosmos. And the first thing that map did, once it was finished, was tell us we don't understand the force that makes up most of it, and we no longer know how its story ends. That's not a failure, it's the most honest thing science can hand you, a result big enough to admit how much is still open. So this is the strange moment we're standing in, not the moment we finished understanding the universe, the moment we finished mapping it and realised the map disagrees with us about the future. DESI is still running. Euclid is out there now, building its own map of the dark. Over the next few years, that 4 sigma hint will either harden into one of the largest discoveries in the history of physics, or melt back into noise and hand us our old, cold ending back. Either way, we'll be among the first humans to actually find out whether the universe ends the way we always assumed, or whether we had the ending wrong the entire time. We spent 100 years sure of how it all turns out. We just drew the most detailed picture of everything we've ever made, looked closely, and found the last page missing. We'll come back to this the moment the next data drops. Until then, keep looking up. This is First Signal.